All right, here we are, quarter one, week 3, day 4 of this worksheet. Here we are doing order of operations. Of course, we know that we need to do PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction. All right, so the first thing is parentheses, so we have those right there. 24 divided by 3. What is 24 divided by 3? Well, that is 8. So we have 8 plus 3 plus 3 to the third power. So we've done parentheses, now we need exponents. We do have one right here, 3 to the third power. 3 times 3 is 9. 9 times 3 is 27, so now we have 8 plus 3 plus 27. All right, so then at this point, we just have addition. We know if we add 3 to 27, that gives us 30, and then 30 plus 8 would be 38. So for solving this one, the order of operations, we would end up with 38. Okay, now we find the quotient. Okay, so 11 is not too hard to work with. It's really close to 10, and 10 is a number that we're all really easy or familiar with. So how many times does 11 go in 8? Well, obviously it can't. How many times can 11 go into 83? Well, it can't go into it 8 times because it's going to be 88. So it's going to have to be 7 times. So we're going to put a 7 here, which gives us 77. So to get from 77 to 83, well, 7, 8, 9, 10, that gives us 3, and then 3 more would be 6. So it's going to be 6. Bring down the 7. All right, so how many times can 11 go into 67? Well, it looks like 6 times, right? Because 6 times 11 is 66. That's pretty easy. And we have the 1. We bring down the 8. How many times does 11 go into 18? Well, that would be 1 time. So there's an 11. 8 minus 1 is 7. So we have 7. We're going to bring down the 0. How many times does 11 go into 70? Well, that's going to be back to 6 again. Okay, so 66. Okay, subtract 66 and 70 would be 4. Another 0 comes down. How many times does 11 go into 40? Well, that's going to be 3 times. So we're going to do 33, squishing it in there. So 40 minus 33 is 7. Okay, and then we're going to bring down another 0. So I'm kind of going off to the side here, which ended up being 6 again. Okay, so 6 times 11 is 66. So subtracting that would end up being 4, right? And then you bring down another 0. So it looks like it's going to go on for a while. As a matter of fact, it might go on being 761.636363. Not particularly sure if we didn't keep going, but it looks like it's going to. So the answer to this one, a good enough answer would be 761.636. All right, so now we are going to find this quotient. Looks like we're going to have to do a keep change flip here. So we're going to keep the 2/6 as 2/6. The division sign will become a multiplication sign, and the 2 over 6 will become 6 over 2. All right, so 2 times 6 is 12. 6 times 2 is 12. 12 goes into 12 one time. That's our answer. And then the other thing we could have done right off the bat is looked, any number divided by itself is always going to be 1. So that's our answer to that one. 2/6 divided by 2/6 is 1. All right, so now they're asking what division model is, or what division problem is being modeled. All right, so we know that for this top one, okay, that there is 12 as the denominator. So obviously that's what we're going to put as the denominator for the first one. And then how many twelfths are there? that are shaded. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. So that's 9/12 of something there. Okay, and then what we're doing is we're taking groups of 1/8. Groups of 1/8 and seeing how many of them go into our 9/12. And how many do we have per group? There's 2, right? So it's going to be divided by 2/8. So 9/12 divided by 2/8, and obviously we can see that the answer is going to be 3, right? They're not even asking that, but they're asking for this. 9/12 divided by 2/8 is the division problem that is being modeled down here below. All right, here we're going to find the quotient. All right, so how many times would 18 go into 9? Well, it won't go into 9. So how many times will 18 go into 98? Well, I'm going to think it's going to be maybe 5 times. Let's try that. 5 times 8 is 40. 5 times 1 is 5, plus 4 more is 9. So I'm going to subtract that. I'm going to have 8 and 7. How many times does 18 go into 87? Well, 5 was 90, so maybe 4. Let's try that. 8 times 4 is 32. 4 times 1 is 4, plus 3 more is 7. So if we take 87 minus 72, we're going to end up with 15. Okay, so that's a little bit less than 18, so that works. So let's bring down the 6. I forgot to put the arrow there for that one. So now we're trying to get to 156. So that's going to be a pretty big number. Let's try 8 for that one. 8 times 8 is 64. Okay, 8 times 1 is 8, plus 6 is 14. So subtract that. So if we subtract 156 minus 144, we're going to equal 12. All right, at this point, we're going to have to do that, bringing down the 0. All right, so how many times does 18 go into 120? So I was thinking maybe 7, but I think that's going to be a little bit too high. So I'm going to try 6 and see if that one works. Okay, 8 times 6 is 48. 6 times 1 is 6, plus 4 more is 10. So we're going to take 120 minus 108, and that's going to give us 12 again. So we're going to bring down another 0. Okay, so 18 goes into 120 6 times. 6 times 8 is 48. So this is going to keep happening. So what it comes down to is the answer is going to be this number with the repeating decimal. So it's going to be 548.6. It's an 8.6. And you could put a line over top of it because it's just going to keep going on and on and on for forever. So 548.6 is the answer. All right, so now we're going to find the product, which means we're going to have to write this so we can work it out correctly. Having trouble getting there? Okay, here we go. 32.32 times 2.1. Remember, it's multiplication, so we're not going to line up the decimals. We're just taking this problem and rewriting it. All right, so 2 times 1 is 2. 1 times 3 is 3. 1 times 2 is 2. 1 times 3 is 3. That's the best. All right, so then we go to putting our spacer in there. 2 times 2 is 4. 2 times 3 is 6. 2 times 2 is 4 again. And 2 times 3 is 6 again. So then we're just going to add these up. 2, 4 plus 3 is 7. 6 plus 2 is 8. 4 plus 3 is 7 again. And 6. Now we have to look up here and see how many numbers are to the right of the decimal. The answer is 3 numbers to the right of the decimal. We're moving it over 1, 2, 3 places. So the answer is 67.872. 67.872 is the product. All right, well, it's wanting us to find the quotient again of numbers that have decimals. But the main thing I want you guys to do on this one is basically rewrite this so that it has no decimal in the divisor. Okay, so we're going to move this over one place, and instead of 1.7, we're going to make it 17. Then we're going to put our division box. Since we moved this over one place, we're going to do the same thing with here. So it's going to be 8,024. So instead of dividing it into 802.4, it's going to be 17 into 8,024. And I already did work this out, and I'm not going to work all the way through a quotient again. So I'm going to go ahead and just tell you that the answer is 472. 472 is the answer to that one without working it all out. If you want to work it out to get practice, you know that if you get this answer, you got the correct answer. But the main point I wanted to get on this one is moving the decimal so that the divisor does not have a decimal in it. All right, so Cassie has 8 red marbles and 12 yellow marbles. Her mom doubled her red and yellow marbles for her birthday. Use distributive property to show how many marbles Cassie has. All right, so basically what we can start off with is we know that she had initially, 8 red marbles, right? So she had 8 red marbles plus she had 12 yellow marbles. So she had that, and if we add those together, she had 20 marbles, right? It says her mom doubled her red and yellow marbles. So both of them were doubled. Use distributive property to show how many marbles Casey has. So basically what we can do is, since we know it was doubled, we just do that. So 8 plus 12, we already said is 20. And then we can do, why did I do that? We do 20, and then 20 times 2 is equal to 40. Okay, so we can say that she has 40 total marbles, or we can also say that we have 2 times 8, which is 16, and 2 times 12, which is 24. So now she actually has 16 red marbles, and she has 24 yellow. So those are all the different ways that we can utilize this. We can turn it into basically an expression, and then we can kind of solve it and either find the total marbles or find out how many red and yellow marbles separate that Cassie has. All right, that's all for that one. Ms. Smith has 28 6th graders and 35 7th graders for math. If she wants to break the 2 grades into identical groups without any students left over, how many students will each group have? Okay, guys, well, it seems to me that we're obviously going to have to find out the greatest common factor. So the biggest number that goes into both of these is going to end up being the groups that we can have without having anyone left over. So let's go ahead and do that. All right, so here we have all of the factors of 28 and 35. We did 1 times 28, 2 times 14, and 4 times 7. Those are all the different multiplication problems that will get us to 28. And the only things on 35 are those two. So what number is the largest that's in common with both of them? Well, that would be the number 7. So how many students will be in each group? There's going to be 7 per group. Okay. Well, we know it's 7 per group. Slow down. There we go. All right, so that's our answer for that one. There is 7 per group.